So now we're going to talk about compound interest. What's the difference between compound interest and simple interest, right? So I said, if you remember, for simple interest, if I invested $100 for say 5 years, every year I would get $10, right? And so at the end of 5 years, I would get $150. So basically, what receives interest is only my principal. Whereas what happens in my compound interest, if I say, let's denote that by CI, let's say I invested $100 for 5 years. Well, what's going to happen in the first year, this is the amount that was invested, so I'm still going to get 10, right? So for 1 year, it doesn't matter which one you choose. But for my second year, what happens is my principal now is not 100, but it's 110. So I'm going to get interest not on $100, but on $110. Okay, so it's going to be 10% of that, which now is $11. So already within 2 years, you see that I have slightly more amount in my compound interest depending on my simple interest. So the main difference between compound and simple interest is, in simple interest, it's only a principal, that's that initial amount that you deposit, that's going to get interest. Whereas here, you get an interest on the interest that you earn as well, right? So these will typically give you more money in return than a simple interest account, okay? So then how do we calculate compound interest? So let's look at the formula for calculating compound interest. So the compound interest formula is given by A equals P times 1 plus R over N, and all of this raised to N times T, right? Where A is the final amount after T years, okay? P, just like in the previous one, is going to be your principal or invested amount. Okay. R is always your rate of interest. Remember, R is always reported as a percent but used as a decimal, okay? T is your number of years or time, and T will always be in years, okay? And then N. N is how many times compounding occurs, right? So sometimes compounding occurs annually. That is, you get paid interest and then you get paid interest every year. Whereas sometimes compounding might occur semi-annually. That is, it happens twice a year. Sometimes compounding might occur quarterly, in which you get paid interest 4 times a year, right? Or you could have monthly, which is 12 times. So N is nothing but the number of times compounding occurs. In 1 year, okay? So let's take an example and see how this works. Okay, so let's take this example. So we have Arya deposited $3,000 in a bank at the rate of 3% compounded quarterly. All right, so how much money would she get back at the end of 10 years? So let's first see what we have. So we have the principal, and our principal is how much she deposited, which is going to be $3,000. Right, then we have our rate of interest. Well, R is going to be 3%, which is 0.03. And then it's compounded quarterly, and we have 4 quarters in a year, so N is going to be 4. And then at the end of how many years? At the end of T years, which is 10 years for us. Okay, so let's go ahead and feed this in our formula. We have A equals P times 1 plus R over N, all of this to the NT. What does that give us here? That gives us 3,000 times 1 plus R is 0.03 over 4 to the 4 times 10, right? Now, if you look at the exponent carefully, 10 is your years, N is the number of number of quarters I have in 1 year. So in 10 years, I'm going to have 40 quarters, right? If in 1 year I have 4 quarters, in 10 years, I'm going to have 40 quarters. So let's go ahead and compute this. So we get, if you solve the thing inside, I'm going to get 3,000 times, I have 1.0075 to the 40. Okay, and if you compute that, you get 4,045 0.05. So this is the amount that she's going to get back at the end of 10 years, which means in 10 years, the amount of interest she earned was $1,045.05.